After learning the compound inequalities connected by AND, in this video we'll learn the compound inequalities connected by OR. Let's take a look at these two basic examples. In this example, we need to solve x smaller than 1 or x greater than 4. If we have the word AND here, that means we need both of them to be satisfied. But if we have the word OR here, that means we just need one of them to be satisfied. Again, we can make use of a diagram to help us. For x smaller than 1, we can draw an arrow like this. And then for x greater than 4, we can draw something like this. And then we can find out the shaded region concerned. For AND, we need to look for the overlapping region, but for OR, since we just need one of them to be true, so we just need to look for any shaded region. And then in this example, we should know that the shaded region is x smaller than 1 or x greater than 4. That means the solution in this question is just the same as the question itself. That means when we have compound inequalities like this, we cannot do any further simplification. And then for this example, we can also make use of a diagram. We have -1 here and 3 here, and that is x greater than or equal to -1. And that is x greater than or equal to 3. And now we can shade the regions. For OR, we just need to look for any shaded region. That means in this diagram, we should know that any numbers greater than or equal to -1 are shaded. That means the solution in this case is x greater than or equal to -1. Let's take a look at some more examples. In this example, again, we can solve the inequalities one by one. On the left-hand side, we have 2x smaller than or equal to 8. That means x is smaller than or equal to 4. And then on the right-hand side, we have 3x smaller than -3. That means x is smaller than -1. And then we can use a diagram to help us. We have -1 here and 4 here. X smaller than -1 is somewhere here. And then x smaller than or equal to 4 can be represented by this arrow. And now we just need to look for the shaded region, any shaded region. That means the result is simply x smaller than or equal to 4. And then in this example, first of all, we solve this inequality. We have 2x greater than or equal to 14. That means x is greater than or equal to 7. And then for this inequality, we have 3x smaller than or equal to -6. That means x is smaller than or equal to -2. And then we can draw the diagram. We have -2 here and 7 here. X smaller than or equal to -2 is represented by this region. And then x greater than or equal to 7 is represented by this region. Now we need to look for any shaded region, but not the overlapping region. And here, as we can see, the result is simply x smaller than or equal to -2 or x greater than or equal to 7. This is our final result for the solution of this set of compound inequality. Now let's take a look at this special example. As usual, we solve both inequalities one by one. First of all, we have 6x minus 3 smaller than 5x. That means x is smaller than 3. And then on this side, we have minus 4x smaller than minus 12. And then we divide minus 4 for both sides. That means we need to flip this inequality sign. So we have x greater than 3. And now when we draw the diagram, we have 3 here, and that is x smaller than 3. And this is the shaded region representing x smaller than 3. And then we have x greater than 3. And this is the shaded region concerned. Now we can see that all the numbers are shaded except number 3. In this case, we can represent our solutions in this way. We may say that x is smaller than 3 or x is greater than 3. Another way to represent the solutions in this case is to write down the solutions are all real numbers except 3. Both are correct. You may present your solutions in either way. Finally, let's take a look at this example. For this inequality, we have x to be greater than 10. And then on this side, we have 4 minus 2x greater than minus 18. That means minus 2x is greater than minus 22. That means x should be smaller than 11. And then we can draw a diagram. We have 10 here and 11 here. X greater than 10 is represented by this shaded region. And then x smaller than 11 is represented by this region. Now this question is presented by OR, but not AND. When we have AND here, that means we need to look for the overlapping region. But now we have OR here. That means we just need to look for any shaded region. And in this question, as you can see, all the numbers are shaded. That means we should conclude that the solutions are all real numbers.